Good morning, students. Now we'll be continue the session. In the last session, we discussed about the square cases in different charges are placed at the corners of the square. The force experienced by the charge at the center as well as the charge at any corner we discussed. And now we'll go for another important concept called here if two pit balls of each of mass, pit ball in the sense like a foamy type of light material balls which is coated by conducting material, such kind of balls, each of mass is m holding a charge q, each are suspended by silk threads and those threads are equal in length from the same point of suspension and they move apart due to the repulsion. So due to because of same charge, what happens, the two pit balls will be repel each other. The separation between the balls is 2x. Each of string makes an angle theta with vertical. Here what are the questions they may ask you in this concept, will be discuss it here. Now we'll be go for this concept. The diagrammatically will be show you. First initially, if you take a rigid support and two pit balls each of mass m is holding like this. Now these are the two pit balls each of mass m. If the charge was not there, they will be like this, it will be there. Whenever if they give charge, what will happen, these two will be acquires equal charges, so they will be gets repel each other by the Coulombic repulsive force. If the given provided charge, what will happen here is the two charges will be repel each other like this. They will be reaches like this. They will be repel each other by what force, in the sense Coulombic repulsive force. This is the thread length, silk thread length is L, and what that mentioned here is each one is making an angle theta with vertical. So in this direction, this is the charge q and this is the charge q. They mentioned here suspended and holding each charge is q and each mass is m. Now you may understand what is the force is exerting on each other, in the sense that force exerted one over the other is Coulombic repulsive force. So the Coulombic repulsive force is in this direction, because this will exert Coulombic repulsive force is this away from it, and weight, it having some mass m, so its weight is mg is downwards. And if you make it a triangle like this, this is the point of suspension O and this is BA and this is B, and if you take this as a C, so and they mentioned here the separation between the two balls is 2x. So totally the separation between the two balls is 2x, in the sense it is x, totally separation is 2x. Now here what is this angle of how much angle made by the how much of deflection taken place, and as well as what is the tension in the string, and if they are asked such kind of questions and how much of separation taken place, x value if they ask, in those we can be discuss the cases. Now first will be go for the resolution concept. Now when a weight is deflected from the main position, what happens here is the tension will be tension is always towards the point of suspension, say T. This is the tension in the string T. Now this tension, if you resolve into components, now you can observe this is angle theta, this is also be angle theta, so this is a T cos theta and this will be T sin theta. Then from this diagram you may understand that at this position this charge is equilibrium, means net forces acting on it are balances, means net forces acting on it 0, or else forces are balanced, means right hand side Coulombic force is balanced with tension component T sin theta, and weight mg is balanced with T cos theta. So you can write at equilibrium, so at equilibrium T cos sin theta is Coulombic repulsive force, T sin theta equal to Coulombic repulsive force F, that is equals to 1 upon 4 pi epsilon naught into here q1 q, q2 is q square by what is that about the distance here 2x, so 4x square, and next T cos theta is balanced with weight mg, so T cos theta is equal to weight mg. Then if you divide these two equations, then let it you take as a 1 and 2, let you take as a 1 and this is you take as a 2. Then equation 1 divided by equation 2, if you taken t sin theta, t gets cancelled, sin by cos in the sense tan theta equal to f by mg. So from this theta means tan inverse of f by mg, provided if you know the Coulombic repulsive force as well as the weight of the ball. And later if you square it and add these two, means 1 square plus 2 square, if you take it t square sin square theta plus t square cos square theta, t square sin square theta plus t square cos square theta, that is equal to f square plus mg square. Then t equal to, will get root over f square plus mg square. This is the tension in the string. So if they ask tension, if you know force and weight of the pit ball, you can able to use this formula. If they ask angle, how much it will be deflects from the main position or how much it will makes with the vertical, that angle you can find by using this equation. Sometimes they not mention regarding the weight and force. Instead of that, they give the length and separation. If the length and separation if they give, how can we write that also we can be discuss it. Another point here is from this triangle O, what here O AB, if you taken from triangle OAB, lengthwise if I write OAB, this is separation x and this is length L, then this will be what, root over L square minus x square. This is L square minus x square. So in force wise you can understand that force wise if you observe, so same triangle OAB, the weight is vertically downwards. This is the force mg and this is the tension in this direction, along AO direction tension T is there, and the Coulombic repulsive force direction is along this side. Now these two triangles, like you can apply the triangle of forces. Triangle of forces, if you take it, that force mg by its corresponding side, that is mg by root over L square minus x square is equal to tension T by L is equal to Coulombic repulsive force F by x. Then we can write from triangle of forces, we can write that from triangle of forces, see from triangle law of forces, we can write that here the weight mg by root over L square minus x square is equals to f by x, that is equal to, and we have one more tension T by L. So this is the formula, you can use it. Suppose if you know weight and force L, you can able to find length. If the length and mg and f they given, using these two relations you can able to find the x separation. Tension if you know, you can length if you know, separation if you know, you can able to find the force. So whatever the any three unknowns are known to you, you can use this relation, you can able to find the what is the unknown they are asking to you, you can able to solve by using this relation. Next we can go for another case, that if the separations here they provided the separation and all x as well as the mg and that relation we discussed here. Now this separation value if they ask, means how much of the string, the two pit balls will be separated, that x if they ask you, how can we solve? The next case is the separation between pit balls. So separation between pit balls, how will be solved here is in this to find the separation we are taking that angle is small case. We are treating the angle is because this separation is very small. So I am treating if angle is very small. Then I'm drawing that again, the diagram here. You can see like this it was there. So this is length, separation, root over L square minus x square. This is the angle. This is the point of suspension. Here weight is mg, pit ball weight mg, and this is the Coulombic repulsive force F. So you can understand this is F in the sense this is also F here. This is mg, can take it. Then tan theta, if you are taken, tan theta is nothing but you can write as a tan theta is nearly as a sin theta. Why? Because angle is very small, we mentioned. So angle is very small, sin theta can be written as tan theta can be written as sin theta, or else you can write these are theta also. So sin theta, and sin theta can also be written as what? Theta. Okay. Then theta means we can write as theta is nothing but arc length by radius. Angle means, you know, from the sector, this is like a sector. OAB is like a sector. Then arc length angle is equals to arc length by radius. Or else sin theta is equals to x by L, you can write. In that way also sin theta in the sense x by L. Sin theta, that is nearly theta, that is equal to here x by L. That is in terms of lengths. In terms of forces, sin theta can be written as what is that? F by, here we can take it as a tan theta. Tan theta is nothing but we can write what? F by here mg, here this direction of force mg, here also I can write this direction of force F, here also can write. Then tan theta is equals to F by mg, opposite side by this inside, F by mg. See, this is a 3, 4 I am taking. You may understand sin theta, tan theta both are same. Okay. Then I am writing these two, I am equating. Even this is sin theta, this is tan theta. For the small angle, we can treat these two are equal. Then if you equate these two, you can write x by L equal to F by mg. F means already Coulombic repulsive force. That is, we can write as a 1 upon 4 pi epsilon naught into q square by 4x square. Why 4x square? Here actually here one more pit ball will be there, and between these two separation will be 2x. That's why we took here 2x square. So 4x square by weight is mg. Actually here we want the separation, means x we want it. So to get the x, I am taking this x square this side. So here already x is there. So x cube equal to 1 upon 4 pi, means 4 here already it is there. So 16 it will be. So 16 pi epsilon naught q square by, here what will come? X L will be goes to here, q square L by mg. Okay. Then x is nothing but separation. X is nothing but here x is equals to cube, it will be goes the straight. So 1 upon 16 pi epsilon naught into q square L by mg. This is the separation between the charges. Actually separation between the two charges is nothing but 2x. So you have to multiply with 2x. This just we found here x only. Okay. So separation of the charge from the center, from the point of where it is initial it was there, from there to how much it was displaced x, we found this one. So if they ask you, you can directly choose this option, what is the displacement of the charge from initial position. Okay. Next here one more case is there. So we discussed two cases here. One is what tension we found, and if the angle, if they ask, we can find this formula to use this formula to find the tension angle, and also length, so displacement of the charge from the initial position, that is if you know, and any one of the weight of the pit ball or force if you know, you can able to find the unknown by using this relation by triangle of forces. And another one, separation we found by using the small angle. They will provide, so The angle is very small, means if they mention, you can find that time the separation is 1 upon 4 pi, 16 pi epsilon naught into q square L by mg. This is the another result. Here we have one more result is there based on that. What is the one more result is here same case. Here one more result there. What result they will ask you is if they taken here they taken one case. First initially they kept the two charges in air or vacuum medium. At the time the angle is theta. The angle is theta. Now we found here this is charge q, weight is mg, and the repulsive force is f, and this is L x root over L square minus x square. Now the question is like this, they are asked when this one, if the arrangement is placed in different dielectric medium, here arrangement is placed in a different dielectric medium, at that time in different dielectric medium, at that time what angle should not change. So angle should not change, and angle is remains same. So in the above case, the liquid of density, suppose we take a liquid of density and the distance between the balls remains the same, then what is that dielectric constant? What is the dielectric constant? We can discuss it. Because medium changes, force changes, separation changes. So separation changes, what will happen here? Angle changes, but angle should be remain same. Angle should be remains the same, and to make it angle is remains the same, what we are doing here is we are providing this weight in a particular liquid, and dielectric constant K is present to make the separation same. What is the dielectric constant? We have to be mentioned. See, I will show you here. This is the case. Now here some liquid is there. So I showing you here some liquid we kept here. This is a liquid of dielectric constant K. K is a dielectric constant, and as well as this liquid density is rho L. Okay. Now this entire arrangement is placing in this. Now what will happen? The medium is not air. Here it is air is there. Now it is not air. It is a liquid of dielectric constant K. Force changes. And one more important point is now the weight is not in air. Now the weight is in liquid of density rho L. So mg is going to be vary, as well as the Coulombic repulsive force also going to be change. So these two will be changes. So these two will be changes, but what should be remain same? We have to make it theta, we have to make it same. So if angle theta is same, then relation between K, density of the liquid as well as the density of the body. This is the relation we have to find it out, because sometimes they may give density of the liquid and density of the pit ball. They ask what is the dielectric medium of the liquid, or else if they give dielectric medium, they will give the density of the ball. They may ask you what is the density of the liquid which they are located. So if this relation, if you know, you can able to solve such cases here. So understand here, one pit balls are there, they are taken in air. We know the angle of displacement angle made by the silk thread with the vertical is theta. Now this entire setup, if they're placing in a liquid of dielectric constant K and density of the liquid is rho L, to make angle same, so what will happen, if they making angle same, what is the relation between the dielectric constant, density of the liquid and the density of the body, that we will be discussing it. See, now here this is the vertical, this force is a F medium, it is F air, and it is a weight mg dash, we can take it mg dash. So weight in the liquid, but what is remain same? Theta should be remain same. Theta is remain same. So weight mg, this is weight mg dash, and this is F in medium. So here weight is in air is mg, F is in vacuum. So in this first case, tan theta from triangle, tan theta is equals to F by mg. And in when kept replacing in the medium, the tan theta is same angle is there, no? So because same angle is there, there's a tan theta equal to here F in medium by mg dash. Now from these two equations you can write F by mg equal to F medium by mg dash. So F force in vacuum, Fm force in medium. We know one relation, force in medium is nothing but force in vacuum by K times. First initially we discussed this concept. Since force in medium is force in vacuum by K times. So shall I can write like this here. F place, I can write F by K. Or else I will rewrite like this. Fm by F is equals to 1 by K. Okay. Fm by F is equals to 1 by K. So mg dash, if I write here, by mg equal to Fm by F. And one more thing, this is mg dash is the weight of the pit ball in liquid. Mg is the weight of the pit ball in air. In fluids chapter it will come to you. Here mg dash is the weight of the liquid in what? Weight of the pit ball in liquid. Liquid in the means it is not actual weight. It is what? Apparent weight. Okay. So apparent weight mg dash equal to, we have a formula, apparent weight mg dash equal to actual weight. Actual weight meaning is when the weight is in vacuum or air. Actual weight into 1 minus density of the liquid by density of the body. This is the formula. Actually it will comes in the what? Fluids topic. So just you refer that once again. Apparent weight is nothing but actual weight into 1 minus density of the liquid by density of the body. Then mg dash by means apparent weight by actual weight is equals to, we can write 1 minus density of the liquid by density of the body. Okay. So this is the relation of apparent weight to what? Actual weight. Because when a body is in air, it is have actual weight, but when placed in the some fluid, upthrust is acting upward. That's why weight will not be equivalent to actual weight. Weight will be gets reduces. That weight is nothing but apparent weight. So ratio of apparent weight to actual weight is 1 minus density of the liquid by density of the body. So this formula you can refer it from the what? Fluid mechanics. Then I am writing. So you see here Fm by F is 1 by K. Mg dash by Mg means 1 minus rho L by rho B. So 1 minus density of the liquid by density of the body is equals to Fm by here Fm by F, that is nothing but 1 by K. Therefore I can write like this 1 density of the body by density of the liquid by density of the body equal to 1 by K. Therefore dielectric constant constant K equal to density of the body by density of the body minus density of the liquid. So this is the formula. So you should be keep it in mind that this is the relation is there. Sometimes they may give you density of the body, dielectric constant. They will ask you density of the liquid. This formula, if you know directly, you can use this formula and calculate easily without any taking time. This concept is very important for objective purpose. Okay. Next will be go for the next case that here if two charges were there, means like two charges in the sense one more important case is if two charger bodies are there. This is one charger body Q1, this is another charger body Q2, and these two are separation. These two are separated at a distance r. Now what is the force here? F is equals to, if they are present in air medium, the force is 1 upon 4 pi epsilon naught into Q1 Q2 by r square. 1 upon 4 pi epsilon Q1 Q2 by r square. So if they brought into contact and again separated to the same distance and again separated to the same distance, then the new force is F dash. Okay, so if the new force is F dash, what is the new force and the ratio of new force to the initial force? You have to discuss it. Again separated. See, they brought into contact and again separated. Once they brought into contact, what will happen is we discussed the electrification by conduction. You remembered or not when you recollected? Electrification by conduction. When you charge two unequal charged bodies, if you make it into brought it into contact, what will happen means if Q1 is more, some excess charge will be received by the Q2. Q2 is more, some excess charge will be received by the Q1. Like this exchange of charges will be takes place. Till what extent this exchange will takes place means till both the bodies will acquire same charge. Now what will happen when they brought it into contact? They two acquires the same magnitude of charge. That is what? Q1 plus Q2 by 2. And this is Q1 plus Q2 by 2. Now these two bodies will be having finally this much of charges. And what we are doing again, we are keeping the balls same position where we brought it into contact R. But initially they have Q1 Q2 charge, but once you brought it and again separated, the charges were becomes to Q1 plus Q2 by 2, Q1 plus Q2 by 2. And what about the new force is F dash equals to 1 upon 4 pi epsilon naught into what here Q1 plus Q2 by 2 whole square by r square. Therefore ratio of the charges F dash by F is equals to what you can write here. This is the F and this is the F dash. F dash by F in the sense we have the result that Q1 plus Q2 by 2 whole square. Here Q1 Q2 it will be there. Then 1 by 4 pi epsilon naught r square will be cancelled in both cases. So then you can write Q1 plus Q2 whole square by 4 Q1 Q2. This is the result. You have to keep it in mind when two pit balls are there, any two spheres are there, or any two charged bodies are there. Initially, if they are separated by distance r, once they brought into contact, again separated into the same distance, the ratio of forces, if they ask you, just you can use this formula to solve such kind of numericals. Q1 plus Q2 whole square by 4 Q1 Q2. Now this is another one. Now we can go for the another concept, that is we have to discuss the equilibrium of what? System of charges. Equilibrium of system of charges. Now we'll go to that concept, equilibrium of system of charges What is the meaning of equilibrium system of charges? Means equilibrium meaning is, so if the net forces acting on the system is zero, or else we can also say net torque acting on the system is zero, then we can say that system is in equilibrium. So we can say that net force F, net force is zero, or net torque is zero, then we can say that system is equilibrium. Then we can say the system is equilibrium. So if a system is there, the net forcing acting in the system zero, or else net torque acting on the system is zero, then we can say that system is equilibrium. Here types of equilibriums are there. So types of equilibrium means types of equilibrium. One is a stable equilibrium. Stable equilibrium. Stable equilibrium meaning is from the mean position, if you disturb the body, means it is again having a tendency to come back to the same position. For example, like I am telling in mechanics way, if you take a bowl and if you take one marble here, and if you displace the marble in either side, what will happen? This marble will be again come back to the same position. Then it has a tendency, if you move from this main position, what happens? This ball again will be come back to the same original position. Then we can say this is in what? Stable equilibrium. Stable equilibrium. So stable equilibrium in the sense, you observe it in electric charges, we can say like this. So a charge is said to be in stable equilibrium if it is a tendency to return to its position when disturbed. So if it is having tendency, if it is having tendency to return back to the what we are discussing, return back to its position, then we can say what we will say, that is stable equilibrium. Let us take the example in case here Q1 one charge, same Q1 another charge, two charges are there here. Then we can go for these two charges. Here middle one charge small q is there, the midpoint, the distance r/2. So if you disturb it either side, it is at actually equilibrium. Why? Because net forces acting on it is zero, because both will be exact same force, so net force acting on it is zero. But once you disturb it from this position, either right side or left side, what happens here? If it is pushed towards right side, what happens here? F more, F2 is less. Again, what happens? It is more, this charge will be repel. More it will repel, so that's why it is again try to be come back to the same position. Either if you disturb to left side, again the repulsive force exerted by this charge is increases. Then again it will be come back to the same position. So either if you move this side or this side, it will be again reaches back to the same initial position. Then we can say this type of equilibrium is stable equilibrium. If unstable equilibrium is there, means if it is not having a tendency to return back its position, that is what we can say unstable equilibrium. So next you can take that unstable equilibrium. What is the meaning of unstable equilibrium in the sense of mechanics wise? If you take a bowl in vertically and if you place a marble here and if you disturb it from the either position, if you just move, it will go down, but it won't be come back to its position. Then we can say it is a unstable equilibrium. Like the same way, so unstable equilibrium means if it is not having tendency to return back to the initial position. back to its position, means where it is there, to that position it is not having tendency to come back. Let us take one is minus q1, same here, and another one is plus q1. One is minus q1, another one is plus q1. Now here you have a charge q. So let us at this instant it is having equilibrium position. But once you move this side, what will happen here? This charge will be more attracted by this, and this is what happens. Repulsion is weak, and what happens here? Attraction is more. Then once you move this side, it is reaches to this charge only, but it won't be come back to its position. So it won't be come back to its position means this charge not having tendency to come back this side. Then we can say this time this charge is not having a stable, it is having a unstable equilibrium. So that is the thing you can understand. So here we can go for one example. If, and one more is there, that is neutral equilibrium. That neutral equilibrium we will be discuss later about it. So here one example I am taking, having one is a charge arrangement is there like this. We have a charge q, you have a charge q here, and these two charges are separated by distance r. So what charge, if you locate at the center of the line joining the two charges, at the center of the line joining the two charges means it is r by 2. So here which charge you locate it, means what is this charge, even polarity wise as magnitude wise, then this system should be equilibrium. System should be in equilibrium. So equilibrium. So that is also important one. You have to understand clearly. System equilibrium means this is 1, 2, and 3. Anyhow, this is equilibrium. So those we will not discuss about it. System equilibrium means not only this one. So here, this one, this charge or this charge also should be equilibrium. Means you should understand that force experienced by this charge q by the remaining charges. What are the remaining charges? Capital Q as well as here another q. If it is 0, then we can say the system is equilibrium. So capital Q is equilibrium. So that is okay. Next, the charge at 1 is equilibrium when force on 1 due to second charge plus force acting on the first charge due to third charge, if it is equal to 0, then this will be equilibrium. So we are taking that F12 in the sense, what is the force here? F12 in the sense Q1, Q2 or Q only, and the separation is R. So 1 upon 4 pi epsilon naught 1 2 means Q into Q square by distance is R square plus F13. F13 in the sense one is small q, another one is capital Q. So 1 upon 4 pi epsilon naught into what? Capital Q into small q by, between these two separation is what? R by 2 whole square is equals to 0. Then if you can common, you can take it common, and remaining what will be remains here is q will be remain, and here capital Q 4q it will be there because 1 R square by 4, and common is what? 1 upon 4 pi epsilon naught q by R square is equals to 0. Then this product is 0 means you can make it send right side, if you send it 0, then 4 plus q plus 4q is 0, therefore q is equals to minus q by 4. So which charge, if you locate it at the center to make the system equilibrium? Minus q by 4. This is also the standard result. If two equal charges is there, middle what charge if you place it, system equilibrium means, and so this charge by 4, and polarity is negative. Okay, Why? Because it should be attracted, so it is a negative charge. So remember, this is also one of the standard result, okay, to make it system equilibrium. Next we go for the system equilibrium system for triangle case and the square case, okay, the next session.